All right, welcome back. So I am on the second page of the notes sheet that was on Canvas. And these are just some problems for you to work to give you a little more confidence with your calculations and all of that. There are a couple of problems on your assessment, so I figured that it would be a good idea to do a couple practice with you because it's been a little while since we've done some calculations. A couple of notes that I want to just point out. First of all, I would very strongly encourage you to use the guess method when you're solving these problems. So go ahead and do that. Remember, givens, unknowns, equation, then substitute and solve. So that's one thing that I wanted to point out to you. The other one has to do with your calculator. If you have a calculator that does scientific notation, I would strongly encourage that you pull that out. I know that some of you have a little anxiety when it comes to scientific notation, and I'm just going to let you know that by the nature of these types of problems, we do have to deal with it. I'm going to talk you through a way um, to kind of ease your anxiety about that if that's something that is true for you. But I just want to make sure that everybody's kind of ready to go and have your tools ready with you. Okay, so question one says the mass of the sun is 2 times 10 to the 30th kilograms, and the mass of the earth is 6 times 10 to the 24th kilograms. The earth orbits the sun at a distance of about 1.5 times 10 to the 8th meters. I guess that should maybe not say away, but either way, it doesn't matter. Um, so, first of all, those are pretty big numbers, right? We're talking about the sun, which is enormous, and the earth, which is still pretty darn big. So I just want you to be kind of like aware of what we're talking about size wise there. It's a lot of stuff. Question part A says, how does the gravitational force exerted by the Earth on the sun compare to the force exerted by the sun on the Earth? So this is really just a thinker question. The force of the Earth um, on the sun as compared to the force of the sun on the Earth. Friends, if we were going to look at the equation, remember to find gravitational force, Fg is equal to G m1 m2 over r squared. This is the mass of the sun. This is the mass of the earth. This is the distance between them. It doesn't matter which number's first. It doesn't matter at all. And in fact, it should not surprise you that those two forces are indeed the same, right? The force of the sun on the earth is the same as the force of the earth on the sun. Which one's doing the acceleration or doing much more of the acceleration? Well, that would be the Earth. Why? Because the Earth's a whole lot smaller, right? We know that A is equal to F over M. And so if we've got a really, really big mass, that means that the acceleration is going to be a lot smaller, right? That's what we're talking about. I just wanted to kind of point that out. That's just Newton's third law at work. It's just kind of cool. All right, let's take a look at the actual calculation part of this question. Part B says, how large is the gravitational force between the sun and the earth? And is it attractive or repulsive? So let's take a look. We're gonna follow that good guess method. So we're going to start by writing down our givens. They're all right up here. We know that the mass of the sun is equal to 2 times 10 to the 30th kilograms. And we know that the mass of the earth is 6 times 10 to the 24th kilograms. We also know that the distance between the sun and the earth, this is just kind of from, the ingrained habits that I have. I write S and E for sun and earth, but you can just write the radius because there's only one in this case, is 1.5 times 10 to the 8th meters. And the other given that I'm going to go ahead and write down is the universal gravitational constant. That's, remember, big G, not to be confused with little g. Little g is the acceleration due to gravity on Earth. We're not dealing with that here. We're dealing with the big universal gravitational constant, which is actually really little in the in all reality. 6.67 times 10 to the negative 11. Remember, it's those funny units. I just got to hit myself there. Newton meter squared per kilogram squared. So those are my givens. I need to figure out what my unknown is. Well, it says right there, how large is the force? So that's really what we're looking for. Fg is a question mark. My equation is going to be the one that we just figured out in the notes before. Fg is equal to G m1 m2 over r squared. quick clarification, some people want to know, is everything divided by r squared or is it just the m1 and m2? Friends, it does not matter. When you're putting it into your calculator, it is really important to make sure that everything in the numerator gets multiplied together and that everything in the denominator is together. So I would strongly encourage you to either do things very much step by step on your calculators or make sure to use parentheses liberally, right? Use lots of them so that you can keep track of what's going on. So now we're going to go ahead and plug in some numbers. And I've got lots of space here, which is nice. And I'm going to go ahead and write it out all the way out so I don't get confused. So 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared times, it doesn't matter which one's M1 and M2 because you're multiplying. 3 times 4 is the same as 4 times 3, right? So either way, I'm going to go ahead and write it in the order I have them written down in my givens sheet, or my givens list. So I've got 2 times 10 to the 30th kilograms. That's the mass of the sun, times 6 times 10 to the 24th kilograms. That's the mass of the Earth. I'm going to go ahead and divide that all by the radius, which is 1.5 times 10 to the 8th. Oh, excuse me, friends. I have a typo here, and I forgot to fix it. I fixed it on my notes, but I did not fix it here. On your sheet, it will say 10 to the 11th, but on the sheet that I had here, I just didn't get that changed. I apologize. These should both be 10 to the 11th meters. I forgot to convert from kilometers to meters when I was copying down values from Google. Please excuse me. Okay, this will make for better results. Okay, so 1.5 times 10 to the 11th meters, and we're going to square that whole thing. Okay, so now you've got a choice. You can go ahead and plug this into your calculator in all of its glory. Again, I would strongly recommend that if you're going to do that, you put parentheses around the numerator and then parentheses around the denominator, making special note to put the squared inside those parentheses as well. When you do that, when you plug it all in, the answer you should come up with is about 3.6 times 10 to the 22nd newtons. Okay. Now, if those exponents are kind of making you anxious, if you're trying to figure out another way to do this problem without kind of shutting your brain down, or if you don't have a calculator that can do exponents, I'm here to help. Here's what you can do. You can take all of the numbers, not the exponent parts, all of the numbers and do the mathematical calculations you need to with those. So by that I mean multiply 6.67 times 2 times 6 and then divide that by 1.5. And if you plug that into your calculator, you should get 30, I got 35.7 when I did that. And then you can think back to your math skills that you learned. I don't remember which math class you would have learned it in, but hopefully you can think back to those exponent rules and remember that you can add exponents if the numbers are being multiplied. So add negative 11 plus 30 plus 24, okay? And then you're going to subtract the exponents that you're dividing by. Now I also need to make sure that I said this appropriately so that I'm not confusing you all. To get the 35.7, what I'm doing is 6.67 times 2 times 6 divided by, I don't think I said this before, 1.5 squared. So you've got to multiply that or do 1.5 times 1.5. Okay, that should give you the 35.7. And then to find that other part, to figure out the exponents, you can do negative 11 plus 30 plus 24 minus, this minus is coming from the ones we're dividing, minus 11 minus 11. Okay, and from that, this is the exponents. You get a 21. So that's your exponent. So we can put these two things together and we get 35.7 times 10 to the 21st, and that's not in super nice, like scientific notation, but it really would be then 3.5 or 3.6 times 10 to the 22nd newtons, which is indeed the same as what we got here. Okay. If you need more details than that, if you would like more help with that, please don't hesitate to send Mrs. Murphy or myself an email to just ask for help walking through that. We're very happy to help you with that. All right, that is practice problem number 1.